Hello everyone, in this video we're gonna learn about the integer exponent power and its properties. The main formulas of this topic that you see. Okay, let's start with just the first two laws on our list. They simply tell us that anything raised to the first power is itself. And anything raised to the zero power is just 1. Okay, and because we already know about exponents that are hidden integer values, like x to the second will be x multiply x, and x to the third equal to x multiply x multiply x. Let's talk about life here. If one person does good to 5%, if this person go and do good to one more person, 5 multiply 5, person 25 more will be benefit from you. Okay, that means we've pretty much got things covered, right? Not so fast. Don't forget that integers can have negative values too. For example, what if we had the expression x to the power of -1? The next law on our list tells us how to interpret a negative exponent. That law says x to the negative nth power equals to 1 divided by x to the nth power. And if you think about it, that kind of makes sense. A negative number is the inverse and of its positive counterpart, and the division is the inverse operation of multiplication. Right? So a negative exponent basically reparated division. X to the -1 will be to 1 divided by x, and x to the -2 will be 1 divided by x squared. Okay, here is an example that will help you see that's true. 4 power of -2 multiply 7 power of -2 equal to 1 divided by 4 square multiply 1 divided by 7 square. And equal to 1 divided by 16 multiply 1 divided by 49 equal to 1 divided by 784. The next law tells us how we can take a number raised to a power and then raise that to a power. As you can see, x n x m n. As you can see, it shows an expression x to the power of m, and group it inside parentheses, and then that wheel group is being raised to x nth power. Where have you saw our list of laws, and we're gonna look at the next two as said, because they tell us how we can multiply and divide expressions that have the same base. Okay, the first law says that if we have the base x with exponent m being multiplied by the same x exponent n, we can combine them simply by adding the exponents m plus n, and the second law says if we have the base x with exponent m being divided by same x with exponent n. We can combine them simply by subtracting the exponents x, m minus n. For example, 2 power of minus 10 divided by 4 square, 7 and 7 degree. Okay, it's 4 square equal to 2 square multiplied 2. Okay, so 2 power of minus 10 divided by 2 multiplied 2, 4, and the power of 7. Okay, 2 power of minus 10 minus 4 power of 7, and this equal to 2 minus minus 10 minus 4 minus 14, and divided by 7, and 2 minus power of minus 14 multiplies 7 equal to 2 minus 98, and equal to 1 divided by 2 power of 98. Okay, it's finally time to look at the last 2 laws on our list. The first law shows this group x times y, and that's being raised to the power of m, and it says that you can write it as x to the m and times y to the m. And the second law shows the group x divided by y and the power of n, and it says you can equal to x to the n divided by y to the n. Okay, for example, minus 2 x power of 3 y power of 4 and 2 degree, and this square belongs to each, and minus 2 square multiply x power of 3 square multiply y power of 4 square equal to minus 2 square is 4 multiply x 3 multiply 2 this 6 multiply y 4 multiply 2 it's 8, so equal to 4x power of 6 y power of 8. Okay, next example. 4x power of 4 multiply x power of 6 equal to 4x power of 4 plus power of 6 equal to 4x power of 10. This is answer. And next example, r power of 6 u power of 3 and 4 degree equal to r power of 6 multiply 4 multiply u power of 3 multiply 4 equal to r 6 multiply 4 24, and u 3 multiply 4 and 20. This is answer. And next example, r power of 5 v power of 3 divided by r power of 3 multiply v equal to r power of 5 minus 3 and multiply v power of 3 minus 1 and equal to r power of 5 minus 3 2 multiply v 3 minus 1. This is square. So that's all. Thank you. Goodbye. Thank you for your attention.